Hey guys, we are recording this session so that we don't forget to record it. And the other day we did. That's bad. So there is no other way to describe, but it is just bad that I did not record. I'm sorry about that. So what we did the other day when we were playing around with Ansible, we did a bunch of exercises. And I think we ran out of time when running with the last exercise the other day, which is the last day. So that time we were doing this particular exercise, and I'll just copy that link for us and paste it in the chat window. That's where you will find the exercise link, which is what we were doing. And we ran into an error. The error that we ran into that exercise was, I think, about SNI. Let me just check. SNI, Galaxy, Ansible. That was the error, if I remember right from the last time. So what was the idea behind this error is what I would like to describe, and I will also describe how to resolve it. And not only just this one error, but in general, how do you look at errors and how do you figure out how to solve them? Because they are a problem, right? They will occasionally pop up right in your face and you will have no idea what to do with it. So this happened to me, and I did something that is what I expect everybody to do, which is to do a Google search as to what's going on. So if you have this particular project loaded up in a Git repository, you have to clone it and then make use of it. So that is what we were doing. And we were playing around with that Git clone link. We cloned it here. And then we ran into this problem that I would like to reproduce it for you. I hope I can recreate the problem again because I have resolved it. And the resolution that I did was actually this one-liner that I just pasted in chat window. That's what I did to resolve. And that is now done. So I want to remove that, by the way. When I remove that particular installation, it should recreate the problem. Oh, it's uninstall, not remove. So I would like to uninstall that, and there is no such option. Huh. Did I not type properly or what? Oh, I had to say yes to it. And so I'll say yes. And so it successfully uninstalled that particular library. Now let us see if we can run into the error again. So we have that particular Git repository cloned. By the way, let me give you a brief idea about what that exact idea underneath. Why are we doing that exercise? Like what's the point of the exercise? That's the first thing I should actually say. So I will start a, come on, Notability. I need a white piece of paper. And so there it comes. And here I will describe the idea behind this particular exercise, which actually takes us to the next topic that I want to discuss, which is containerization. So we want to move away from the idea of dealing with virtual machines all over to the idea of dealing with containers. That's the primary goal of this exercise. I want to stop using these guys and more focus on these things: containerization, Kubernetes, and Docker Swarm, and the newer ways of dealing with cloud technologies, as opposed to using virtual machines, which is the old way. It is still useful, but this is a better way. And that's what I want to be able to accomplish. And so we want to transition from here to here, and Docker containers is the underlying technology that we will be using. So what this particular exercise that we have at hand, this one that we are looking at, does is it basically converts this machine into a Docker host. And then once you have this functioning, you can then run everything in a Docker container. That's the ultimate goal I want to go towards. So I want to transition from here to there. So this project, this Git repository, will help us accomplish that. It basically converts a machine that you have. A machine can be, you can call it instance, or server, droplet, God knows whatever names you will come up with. So that's what you want to get to, a point where it becomes a host for Docker. So once we have that host, then we can run containers. And that's what I want to get to. So this is the transition exercise. And when I started running it, it ran into an error. So that error I will like to reproduce. One of the things that we need to do is to actually go to Ansible Galaxy, which is somewhere like here, for example, that location in the Galaxy, which is where we, community stores a bunch of ready-made roles and playbooks and all that. That's the community here, which is behind Ansible. By the way, Ansible was acquired by Red Hat, and today, maybe yesterday, IBM acquired Red Hat. So Ansible is now eventually a part of Red Hat. Oh, sorry, IBM, I should say. What am I saying? Sorry. Ansible got acquired by Red Hat, and Red Hat got acquired by IBM. So all of these things is now an IBM product eventually. Not finalized yet, but it will happen, I hope. At least I hear that it will happen. There is a news about IBM acquiring Red Hat for some $34 billion or something like that. So this community behind Ansible Galaxy, there is this person who has made this contribution, which is basically does exactly what we expect to do. So for that to happen, we need to install that particular role. So we copy that action, bring it here, and then try to invoke that action. So that action invocation requires us to basically run that command. And when we run that command, you will see that it creates something inside our folder here. That folder called roles will get created, because that is the idea underneath, is that let me delete that roles folder completely. And what we want to do is described in the README file, which is to grab that, pull down that role from the Galaxy. That is what I wanted to run. So I ran it, and it got me an error. So the thing that I want to point out to you is, how do you avoid, generally speaking, what was the root of the error, why did it happen, and how do we basically go about hunting down solutions to the problems that we occasionally run into. So here I'm going to now run into the problem. Okay, need to copy properly. So here is the command I want to run, which will go to the Galaxy, grab that particular role created by this gentleman. This is the name of the person. This is the name of the role. And we have to go to Ansible Galaxy and install this role. So that's the action expected. We want to do that action in our command line in the folder, and we run it. When we run it, we might fail. And let's see if it fails. And it failed. So now let us read. This is the most cryptic part. This is also the most, the point where people hit their head on the wall or hard objects and, struggle with it. So that is what you see when you have an error. What do you do now? The best thing to do is to carefully read this thing. The answer is right there in your face most of the times. Just have to read. So let us read. I'm going to read this. So it says, something that you wanted was not installed successfully. Fine. And it failed to get something from somewhere. It failed to validate the SSL certificate. That's the idea, apparently. And it failed to validate because of something. Let's see what happened. So it tells you that make sure that you have managed systems and have a valid CA certificate installed. I guess we have it. We have a proper certificate installed. This is a freshly Ubuntu machine, and it has all the certificates in the etc SSL folder. In that folder, we have all the certificates stored already. It's given to us by default. And so we know that. But then further ahead, we see that there's this reference to the idea that if this if idea, if condition, if the website serving the URL uses SNI, you need Python 279. Well, we have it. We thought we did not, so we checked for Python. Is it more than that? Apparently so. So we checked for Python, and it tells us that the Python is actually okay. So let's go confirm that. I will now check my Python version. So you say Python version, and I see that I have 2713. which is higher than what is written down there. So it should work, but it didn't. Even though we have a higher number, we higher than this number, it still did not work, which is crazy. That's the part that is kind of confusing. When we know it is higher, why are you not working? But apparently this number itself in the error message is wrong. That's what I finally found out. And it tells you that, or alternatively, or you can install URL lib3. That's the answer. That's what we actually ended up doing to resolve the problem. And one of these modules to perform SNI verification in Python. That's what we want to do effectively. So this SNI verification is a need that has arisen in July 2018. That happened because Ansible decided to host the Galaxy away from wherever they were to a new location designated as OpenShift. They migrated to another location and they expanded their certificate, their existing certificate, to include this subject name initialization. I should just check what the full form of SNI is, but it's an extension of your SSL certificates to include other names. That's the underlying idea. And that piece of puzzle is not included in our current installed Python. So that's the reason why we need to get URL lib3 installed on the machine. And that's what I will be doing now to see that the error actually goes away. So I will erase my drawings and illustrations and then put this window, erase the drawing and illustration and put this window on the side. This window, go to the side here, and then I will install the step that I did to finally fix it. Basically, we want to get this installed, URL lib3. And we can do that by saying, pip install URL lib3, and this should do it. But it didn't, because our Python in this particular machine requires super user privileges. That's why we're adding this sudo -h. And then asking it to install URL lib3, it installs successfully. And once it is installed, we should find that this error goes away, which means if you run this command again, it will create a new folder here in the repository called roles, and will grab that particular, it will go grab that particular role from the Ansible Galaxy. And so here is that command again, this time one more time, and now it is downloading it. So what you saw is that the role folder is coming down. It has the role that we wanted, and it is coming from the Galaxy. And it came. We want to use it now. We will use it. And the way we use it is that we are invoking that particular role in a playbook like this. So now let us look at the role itself. So we have a bunch of things inside. We'll go through that detail, but under the hood, let's go at the top level. What does this role do? So if you read that Ansible Galaxy documentation, it will tell you that it does whatever it does. There's a README file here. You can read. It basically installs Docker on these platforms. So you can either get a Debian Jessie box or a Stretch box, which is a Debian OS, or you can get Ubuntu and play like this. So that's one example of a play. Very, very simple. That's what I think very similar to that what we have, except that I have one more extension. I've included kernel package state present. I think that's what I did. Kernel package state present. I included that one extra item. And then I included one more item that is not here in the documentation apparently, which is to accommodate for a scenario when I have a custom username, for example, in my Ansible configuration, which points me to an inventory, which is like host file, where I'm showing it that I'm storing my inventory in a file called hosts, where I have a bunch of different clouds, Google Cloud, Amazon Cloud, Azure Cloud, this cloud, that cloud. And so in there, I have this cases where I can use my own custom name, which is different from root. For example, I could use Ubuntu or Nilesh or whatever I like that may be a case in certain clouds like this one. And so to accommodate that scenario, what I have done here is I have included my username that I choose as a member of the Docker group. So that I can then log into that machine using that username that I have chosen, which is defined in the host file like this, for example. In that case, I should be allowed to log in as Nilesh and still operate on Docker, which is what I'm accomplishing here by including my name, Nilesh, here in this location in the Docker group members. And this definition of the username variable is defined in the host variable section for various clouds. So say, for example, Azure, the name is Nilesh. For Amazon, the name is Ubuntu. For DigitalOcean, the name is root. And for some other machine, like the machine name called late for dinner, the name is root. And for every user, there is a corresponding home location where I need to have the home users directory identified. So that's what I'm doing here, home Nilesh, similarly home Ubuntu. And for DigitalOcean, like machines which give you root access, just the root folder. So that's the definition of variables that I have called out here in the host variables section for variety of hosts that I'm using. I chose the one host the last time, which was this host, DigitalOcean, and we quickly ran through the exercise and we ran out of time. So now what I will do is I'll actually create multiple machines in multiple clouds, maybe all of them. And for that, I need to like speed up. So I need to go create 5 machines, for example, 1, 2, 3, 4, and this is, I don't know what cloud this is. This is actually not a cloud. It can be anything. Any machine you can access using an IP address with a root or some other username, and you have a private key in place and all that. So this private key, as you know already, is needed in your, wherever you have for every machine access, you need to have that key in place. You need to have the Python interpreter selected and identified, which can be 3 or 2, or maybe if you don't say anything, it is 2 by default. If you specifically call out to be used that way. So those are the ideas under the hood. And what I want to do now is to actually make use of this particular play in executing and converting a bunch of different machines from different locations into Docker host. That's my goal with this exercise. And once we have them, we should be able to switch over to using Docker as the foundation for anything else going forward. That's the ultimate goal that I have for us, so that, you know, from starting from the next session onwards, we'll probably most of the time focus on Docker as opposed to using virtual machines itself. So I will actually spend some time even today on, once we have this platform ready, the Docker host platform, we will spend some time on understanding Docker's capability and extend our conceptualization of Docker, and then put more exercises in running Docker. By the way, Docker is installed right here on your command line right there. You have Docker already. You can just open up a container or create, do whatever you want right here in the command line. It already includes Docker. I done it for you already, so that it's there for you if you need. But in this exercise, what we are going to do is convert a machine from some random cloud into a Docker host. So let's go figure that out. How do you do that? Let me just go to a cloud and do this quickly. So I'll just go to some cloud, like we'll go to Azure cloud, for example. So let me just open up azure.com. That's one cloud. The other cloud I'll select is DigitalOcean, the easiest, cheapest. Cheapest. Yeah, cheapest is not the best though. I hope you know that already by now. This is where I sign in, and then I log in, and then I type my password, and I hope I'm allowed in. No, not so easy. Fine, give me a token. The token will appear in my text messages, and that's the token right there. I'll grab it and put it in here. Oh no, URL lib. I don't want to copy URL lib there. I want to get my number, that one here, like that. And then I'm logged in, I hope. And yes, so here I get started with the droplet. In the DigitalOcean cloud, I will select a Debian machine, Debian 9.5, and we'll select 1 GB, and we'll select San Francisco, and we'll select our private key, public key, key pair selections, and then we'll call it Docker on Debian. That's the name of the machine that I want to use. Maybe I want to use matching names that I have. Again, these names are irrelevant. I'm just saying that, I'm just being picky about the names I want to use. So I will choose this name called digitalocean.cloudgd.us. This is, what I would like to actually do. So this will actually illustrate a point, which is how do you address host variables, for example. So I'm using that name. And by the way, this name can be anything you like, but I'm just, for ease of my memory, I'm going to label it like this and create the machine here in the DigitalOcean cloud. In the other cloud, I will go and create a new machine. Get started, and then I want to get a new Azure machine using Ubuntu something. And so here is my virtual machines. And then I want to go to create them in, come on, pay as you go. And this machine will be called, what do I want to call it? I want to call it that name. So Azure. And then I would like to grab that name from there, copy that name, bring it here to the Azure cloud, and that's the name I want to choose. Put that in US West and select 1804. Okay, virtual machine name cannot contain non-ASCII characters or special characters, cannot have dots in between, whatever. So your name will be whatever. And I will choose a cheaper box, not that one. So the cheaper box is coming right up. Hello, $10 box, that one, select. And then I will go select my username as Nilesh, and my public key I want to paste from here. I will grab my public key like that. That is my public key right there. So I'll grab it, bring it here and paste. And then I will create some disks and choose the cheaper disk and choose networking. I have my VPC virtual network already in place. I want to use it. And then I go advanced security groups or basic security groups and allow specific ports like these guys. And then I go to management where I do nothing. Go to configuration where I do nothing. Let's go check the management pieces. Yeah, these are okay. You can leave them with defaults. Go to configuration, leave them with defaults, tags, defaults, review and create, and that creates a new machine, which is where I need to just click a button to start that. And validation passed. Now I need to click the create button. That machine is getting created. This machine should be ready by now. And so here is the machine. We grab the IP address, copy. We put that here in the place for DigitalOcean. IP address is that one. So here is a new one, overwriting the old one. There we have it. Similarly, we'll do the same for the other cloud we are dealing with, which is your Azure cloud. So we line number 3 activated, line number 4 activated. Rest of the lines are not used. I'm waiting for the IP address from our Azure cloud. And I don't have to wait for it, by the way, just so you know, don't have to wait for it. I can run, because I have at least one machine ready. I'll just run it. I don't have to wait for that thing, because waiting is hard for me in general. So I will like to run the play. How do I run it? I just say Ansible playbook, and then give it the name of the playbook. I will just run it without even having the correct IP address. I know my IP address for Azure machine is wrong, but that's fine. It will cause some errors, but that's okay. You want to deal with life in general, as to, the erroneous life. So we will have errors, and that's okay. I mean, just deal with it. So I'm going to copy this and bring it here and see some errors. Let's go see them. We know we are going to have errors in Azure, which is fine, but let it run. So it's going to say, I'm going to connect to that DigitalOcean machine. Are you sure? And I said, yeah, go ahead, do that. So it's going to connect to the DO machine and do its thing. And it will fail on the Azure machine, which is fine. I don't care. What I do care about is I'm not waiting for it. So when it becomes ready, That is, then I will go back here and see if you have an IP address for me, the deployment underway. So eventually when I have the IP address, I will provide it to my playbook, and then I'll run the play again. That's the idea. You don't have to wait for stuff. So while right now DigitalOcean machine is getting ready, our deployment is still underway. We'll wait for it to finish, and when it does, 2 minutes and 10, 11 seconds, eventually we'll get an IP address for this whatever machine, and that IP address is right there. So deployment succeeded. Go to the resource, and here is the IP address. We copy it, copied, go back here, and in our host listing, we'll say Azure IP address. I have the right one now, so we'll say paste and close, and save and close. So now I have the right IP address for hosts in the Azure cloud also, which is sweet. I just need to run the play one more time. I will do that when this thing finishes. It'll report success for 50% of the machines. And for the other 50, we know already. We did not have the IP address correct, so it is expected to run errors, which is fine. But just remember that we are waiting for this line to start. We are waiting for this line to finish. The 2 hosts we have, here is one that we just updated the correct IP address with the name Nilesh and everything else the same. With this is a operating system is, what is the Debian? And here we have an operating system called Ubuntu, the 2 different OSs. We want to convert both of them into Docker hosts. That's the underlying idea. So let us see if we are ready to run the play again. It may have finished by now with errors. So one of them was unreachable. We know that. Not reachable, did not have the right IP address. The other one, success. Which means DigitalOcean machine is ready for us to just play with Docker now that it is done. But let us run the play one more time. And this time you will see that it's asking us to connect to the Azure machine, and I'll say, yes, go ahead and connect, and let's see what happens. It is doing now for both the clouds, but it is running certain things only on certain machines. It might skip a couple of things for one of the 2 boxes and actually do the thing for the other boxes. And if it is already done doing its thing, it will not need to do the thing again, because that's the idea of idempotence. If you have something and you want to do this again, it will, it will begin from an initial state. It will take you to a new state that you want, or I should call it desired state. The state you want it to be, desired state, and it will transition the state from here to there. And if you run it again, it will just go to the desired state and maintain the state. So that's the point of this green color. It is not doing anything on DigitalOcean. The point of yellow color is it is doing something, it is changing something on Azure cloud. That's what this change is happening. And this is doing nothing. Nothing is happening right there. So the green color here for the DigitalOcean cloud, and this Azure is showing you change happening. Change is going on. And you will see that same thing, it is not doing anything in the case of DigitalOcean, no activity. I mean, yeah, it's doing an activity called I am doing nothing activity. So the nothing activity is happening for DigitalOcean. It is not installing Docker again, because there is no need to, but it did install apparently. Let's go check. It did install Docker packages. It added Docker repository to Azure cloud, but did not do anything to the DigitalOcean, nothing. There was no need to. Same here. Ensure etc Docker is present. It was already present here and not present here, so it made it happen. Same thing happening here, installing some requirements. So that is already done for DigitalOcean. It's going to do for the other cloud, which is going to show up. And you can basically replicate the same idea with other clouds if you have that. They're all basically the same thing. They're machines. They run Linux. So you just deal with them just like you do with any other machine. It just happens to be in a cloud, whatever. It doesn't matter. And one of the names of these machines actually is whatever. But these are all irrelevant things. At the end of the day, you're accomplishing a goal. The goal is what we want to make sure that it succeeds. And that's what matters. Everything else, whether it is this cloud or that cloud, or what the name of the machine is, what the underlying OS is, we honestly do not care. Honestly, too much. We care a little bit, but not too much. What we care about is only one thing. Is that person happy? That's the only thing to really worry about, or not. That's what you should focus on. Everything else on the planet is, in the context of business, is irrelevant. Whether you do this cloud, that cloud, who cares? As long as this guy is happy or this lady is happy, that's all you care about. Everything else will automatically fall in place. It doesn't even matter to me or to the customer. I'm done. That's the idea of business, by the way. If you remember our discussions from the goal book, it's about the customer. That's the goal. That's the idea of business. So that's what we're talking about. Is these clouds will come and go, new technology will come and go, but as long as you have your customer and they are happy, you are happy eventually. If not immediately, you will eventually become happy. And that's the goal. So see, green items did nothing on the DigitalOcean cloud, and it did everything that was needed on the Azure, on this cloud. There was no need to do anything, so it did nothing. Green color, change 0, and did 10 changes on this machine and 25 operations on the Azure cloud. And so that's the idea of the two clouds that we had in mind. Now that we have seen this run, let's go understand what's going to do for us. So we will go to one of these machines, like for example, this IP address, which I have from Azure cloud. So I'll grab it and then I will open it up in the command line, like full screen command line like this, so we don't confuse ourselves with anything else. Here we go. So I'm going to SSH to that machine, Nilesh at IP address, and I am connected. Bingo. What do I have here? The machine called whatever. I will check what machine are you, and I will also check what distribution are you. And so it is Ubuntu 18.04 and all that good stuff. But all I really am interested in is finding out if there is Docker installed. And there is Docker. Let's go read what do we get from this. So I'm going to read it now a little bit to understand what did we actually end up with, and what is the point of doing all this? Like, why are we doing this exercise? That's the real question I want to answer. So let me grab my pen and talk about this thing called Docker, which we have discussed a little bit before, but now we are doing it in the context of a cloud. This cloud is your Azure cloud, by the way. And I'm logged in as Nilesh. In Docker info, I'm seeing that I have no containers running, no containers paused, no containers stopped. There are 0 images. Basically, it's a blank, empty slate. I'm running this version of Docker server. I have my storage driver called overlay. That's something I want to talk about, overlay drivers. I am using the underlying file system under the hood is extfs. That's the file system in Linux that you probably have already, you know that already probably. Then I have some of the interesting things here called C groups fs. That is something that I do want to talk about. C groups, something that I want to talk about a little bit. There are some plugins used to allow volume creations. Volume is basically disk. We have a network creation with a bridge type, host type, MAC VLAN type, null network, and overlay network. Bunch of different types of networks options available. This is what I would like to talk about. Okay, that's interesting. There are log locations of various types. There is a swarm idea, which is currently inactive. That is also, we like to talk about swarm. Let us see, runtime is using runc, default runtime, initialized binary, containerd version, this version, that version, security options, kernel version. That kernel version, by the way, is the same as the underlying machine kernel. So let's take a moment to actually note down these things. So I'm going to make sure that I don't miss. So I'm going to open Atom and write these things down. So what I want to talk about is overlay, C groups, networks, swarm, volume, kernel. That's what I want to really talk about, right? So I'm making these notes for me so I can refer to it back and actually make sure that I cover these things. That's what I want to really focus our next discussions on as to what is under the hood in Docker. So let's go see further. What else we have? We have the operating system under the hood, Ubuntu, we know that, Linux OS architecture type, 64-bit. We have one CPU, which is the cheap machine I got from Azure Cloud. So this whatever cloud is a cheap machine. There's only one CPU there. Memory is only like tiny, 1 GB approximately. The name of that machine is whatever under the hood. There's an identifier. There's Docker root directory called varlib docker. That is something that varlib docker is something you should be aware of. It's not directly used, but just be aware of the fact that there's this folder where it stores stuff. The Docker stores stuff. Debug mode is off. Registry is something that is off. We need to talk about registry. And then experimental is false. It is ready for production use. We have live restore is also disabled, and warning, no swap limit support is warning. Or let's call it swap limit. Those are the ideas that I want to really talk about in Docker info in a real context of using this thing on the Azure cloud. That's what we saw here. What I will now do is make sure that I take down these notes in my sheet before I erase my drawings. So I'm doing that right now. Varlib docker, and then we have a concept of a registry, and the concept of swap, limit support. What else did I have? Did I miss much of the important things? Not really, not really. Now let us compare this with the other cloud. So we come out of here, we go to the other cloud. The other cloud is called that IP address right there from DigitalOcean. So we grab it, we go to the terminal, and then we actually, let me erase this red ink. So I'm going to erase it all right now. And then I'll open another terminal, like, okay, like this, like hello. I think this annotation comes in the way when I am typing versus writing. That's what's going on. So that's why I'm not able to just open up Windows on my demand, but now I should succeed. And here is a new window. There we go. So now I'm going to connect SSH root at the other IP address. And this IP address connects us to the DigitalOcean machine. And here we have it on the other end. We'll adjust the font size a little bit and then say, Docker info, what do you got for me? So let's now compare. What are the differences in DigitalOcean versus Azure Cloud? You will be surprised. There are not much. I mean, I thought you knew that already, but I'm just pointing them out to you that there are not much differences. So let's go see them if there are any. Anything running here? Not really. A version is the same. File system overlay 2, same. So most of the differences, let me point out differences for you. The differences are that we have a different kernel version. This is 4.15, that was 4.9, different kernel. The underlying OS is Debian, this is Ubuntu. That's the fundamental difference. What else we have? The machine CPU 1, memory 922, memory 996, both are 1 GB machines approximately, but this one is actually giving us a little bit less memory for some reason, I don't know what. I think just that's how Microsoft gives. I don't exactly know why they do it like that, but who cares? It's approximately 1 GB. It's a cheapo machine. They give you for $5. This one is like $8, $10 or something. Same machine, same cheapo machine, but double the price. This one is 5. This is the same location. You have your identifiers are different, and rest of the things are same. That's what you have here. So basically the same idea. The fundamental difference between this side and this side are that you have a different underlying OS. Like here, for example, we have an OS. Different. Does it matter? Not at all. Not at all, actually. I can very, very clearly say it does not matter at all, as long as you are creating applications that use container technology. You don't need to really worry about what's under the hood. This is Ubuntu, this is Debian. They are both 64-bit, both basically similar machines. They might perform a little different because of this cloud is Azure, this cloud is DigitalOcean. So you might see different in performance. But from a usage perspective, a feature function perspective, they'll broadly be very, very similar. There'll be more features from the cloud side of things in certain clouds than other clouds. But other than that, they are similar. And this is, you can get Debian here, and you can get Ubuntu there. That's not a problem. You can choose your OS very, very easily, effortlessly, as you create the machine itself. Now, having seen this, I will clear this out, clear my red ink, and put this window on the side here, and grab the other window and put it also on the side here. So we have two windows opening, or two windows open on the back side of this Atom editor. And now let us see what we wanted to discuss, these things. So let us understand what are these things. Let me revise a couple of these things in a sequence that I would like to talk. I'll just pick and choose whatever I want to talk about. That's maybe easier. So fundamentally, what is Docker? Let's begin with that. You may have seen some examples of me showing you illustrations and demonstrations, live demos of what exactly Docker can do for us. And so that is what, I'm not going to repeat that. Unless you have questions of that idea, I will do that again. But let's go understand what is Docker doing for us. So we will begin with that understanding of these things, broadly speaking, but in a way that makes sense. So let's begin. At the foundation, these machines, the Docker infrastructure requires some computer here, somewhere. That computer can be real or virtual. By virtual, I mean virtual machine. That's what we obtained from two clouds in our examples. Those two machines are open like this, and we are connected to the whatever machine from Azure cloud right now. In that, either it can be a real machine or a virtual machine. And in that machine, we need to have Linux running. That's a requirement. These days, the requirement is not as strict because there is a Windows version of Docker also available. So you can play in a different, it's a different world altogether. It's a new world. It's a separate world, I should say, separate world called the Windows world, and it plays within that boundary. The rest of the world is huge. And this is the real world. This is big. And this runs in the Linux domain. There is this thing these days called Windows version of Docker that requires Windows under the underlying machine, and then it will run Windows containers on Windows platform, and so it's everything in Windows, and it's all within that box. So that's the idea that exists. But I'm not going to talk about it because it is not open source and it has limited usage. So let me erase that, because I just want you to know that there is this thing called Windows containers. They exist, they operate, they work just like these guys, the bigger brothers, but it's a separate world altogether. So not discussing that, unless you absolutely ask me to, yeah, no, we want to study that. In that case, I'm okay with that. But if you don't tell me anything, I will not cover it. Unless you very, very clearly tell me that, you know what, you want to study Windows, Docker, containers. In that case, I will set up a Windows machine right on this computer screen and we'll deal with that. But you have to ask for it. You have to literally, say, Nilesh, you please cover Windows Docker. And in that case, I will cover it. And I'll tell you why I will do that. Let me tell you that in black and white terms. In black and white terms, you are my customer. So I want to make you happy. So I will do it if you tell me that. If you tell me that, you know what, please cover Windows Docker containers, I will shut up and do it. As simple as that. That's the idea. So I'll leave it to you. You need to decide. Do you want to go there or not? By myself, I'm not going there. Having said, we have some machine running Linux. And that's the dominant way Docker containers are used, by the way. 99%, maybe 95%, who knows? I don't even know how big that other world is. But it is working, it is functional, and all that good stuff. So Linux, under the hood, that's what we have in both these two clouds. Like, you've seen that. Because we know that, we know that we have this container called the whatever machine and the other machine, which is what just happened. We're close. So there are two clouds. Like one is this window. Let me just put them side by side a little bit like that. And there is this DigitalOcean machine and the Azure machine. Let's go connect to the Azure cloud like that. No, not like that. No. Yeah, there we go. So this is connected to the Azure cloud and this is connected to DigitalOcean cloud. So we have that now. Having understood that piece, let us see the first thing. Under the hood, what kernel do we actually have in our DigitalOcean machine? So let's go put this on this side and that one on this side. And ask this DigitalOcean machine, what is your kernel? Why can't I type properly? Because my hands are not in the right location. That's why. Let's go ask the same question to the other guys. Hello, Azure. What is your kernel version? So it tells you that the kernel version I have is matching what I showed you in Docker info. The same exact kernel. And same here. Kernel version is the version that is being used, that is provided by the underlying setup, which means if you have a machine running Linux, it has some kernel here like 4.9 point whatever, that kernel will be used by every container. You have containers running variety of things. They will all be sharing the common container, sharing the common kernel. This kernel, they will be sharing that. Is the idea. So on this machine, if you have multiple containers running whatever you want, they will all be sharing the common kernel right here. That's the idea. The first idea is everybody shares the same kernel, which means you cannot have something different here and that one there and some other thing here and something like that. You have to have the same kernel. That's a given condition. That's one of the key things that are necessary for these containers to run correctly. They should be okay with the idea that they cannot change the kernel on the fly. They are given with what they have and you have to live with that. That's a constraint. So that's one idea. Let us now understand. So I just discussed this idea with you, like kernel, but cross it out. Let's see the second idea. The second idea is about separation of, or rather isolation of containers, like completely isolated from each other. So I will now erase my illustrations and draw fresh ones. The underlying idea is if you have a Linux machine running some kernel, it will create multiple places for you to run different containers in which you can put in applications. Like that. You can have multiple different applications all using the same underlying kernel. And now the key idea to remember is that these containers are completely isolated from each other. Complete isolation, which means They don't share anything, like share nothing, which means they absolutely don't share any connectivity, no files, no CPU, no memory, no nothing, completely isolated. This isolation behavior is created by the fact that in the underlying OS, there is a capability in Linux called C groups, which is a part of the Linux kernel. And what C group stands for is control groups. And so control group technique in Linux allows creation of this isolation between containers. When you create a container, by design, it is completely isolated from anything else on the planet. Not just this machine or other kernels, it is just isolated from every single thing on the planet. It is conceptually similar to you getting an iPhone and turning off your Wi-Fi, Bluetooth, radio, cell phone signal, every single communication shut off. And you put it on the table. That's the idea. Like there's no connection at all whatsoever. It doesn't share your memory with your laptop, desktop, doesn't share your memory with your iPad, doesn't share any memory or disk with any other machine on the planet. It is completely isolated. That's the underlying idea. That isolation is accomplished by control groups. And it is a technique you can read more in Wikipedia if you like, or there are a bunch of places you can find. C groups leads to isolation, complete isolation from each other, which means they cannot talk, they cannot interfere, or cannot mess around with other things that are running on the same machine. What it really boils down to is if you have a, let's see, if you have an application, let's call it this application. If it is hogging, if you know what hogging is, hogging for CPU, that I need CPU, I just need CPU, I'm doing some processing. So this underlying machine has only one CPU. As you know, this one CPU, so it might have more, and you can basically divide the work of these 4 containers into equal parts. And so 25% CPU, this guy gets 25%, this guy gets like that. You divide, but this guy is a hog. So it needs more CPU. That doesn't mean that it will just hog this guy and this guy and this guy's CPU. It cannot. It will be limited to the allocated percent that you dictate. You get to decide how much of a portion of the CPU can you or you willing to allocate to this container. And you set budget limits. That's the underlying idea of swap limit support. One of the ideas is this, swap limits. You're setting limits on CPU. You're setting limits on memory consumption. You're setting limits on storage. You're setting limits on network capabilities. And that's the underlying idea behind limiting support using control group as a technique to enforce these budgetary limitations on container characteristics. You cannot have this container hog 100% of this CPU because if you do allow that happens, then these guys will suffer. You don't want the other containers to suffer like that. If you have a hog here, and so you basically want to do a budget limit and say you can only consume 25% of this CPU because I said so, and that's it. That's the limit. Now what you're looking at is no swap limit support is a warning, is that it's telling you that this machine is incapable of enforcing such budgetary constraints. You have to get a slightly bigger machine and change some configuration in the machine to allow and enable this swap limit support, and you will see that in future examples. So that's the underlying idea behind limitations. So now I'm going to erase all this illustration right now. So all the red ink will go away now. So we discussed the idea of C groups. limits, and kernel. Let's see what else we have, or rather, what is the next idea we should discuss? The next idea we should talk about is the idea of this overlay. So overlay is the idea of called what I call layered file system. You know, under the hood, our machines have a file system called, what's it called? Where is it? It should be listed here somewhere. Yeah, that's the underlying file system, extfs. That's the basic machine-based file system on the Linux machine you have, extfs. That's what we got. But what I want to be able to do is have a unique file system which is layered in its nature. What does that mean? It means that if I want to create the LAMP stack, you know the LAMP stack, right? I hope you remember. So that stack, Linux, Apache, MySQL, PHP. If I want to create that stack, what do I need to do is on top of this, I have Docker. So basically think of it as a Docker host, which is now the case in our examples. So I want to create this setup, LAMP machine. I need to have a container running LAMP stack. So I got the L already here, Linux. And I can use the kernel, it's available here. That is good. So L is taken care of. Now I need to get AMP. So I need to somehow magically figure out to put a layer here containing PHP language. So now I have P. So imagine this is possible. So somehow just create a layer. And so I now have P ready. And what I will do now is find another way to somehow magically put a layer of Apache on top. So I got Apache. Now I need to do is magically put a layer of MySQL. So I put that. And I got LAMP stack now, because if you look down here, I have this layer and this layer and this layer, and then under the hood, I have Linux. So I got LAMP already in place. That's the idea behind a layered file system. So this file system is installed on top of your underlying extfs, and that file system is called AUFS. And you will find somewhere a reference to that here. If I don't find it, I will look up. There has to be a reference to AUFS somewhere here. Where is that? Storage driver overlay file system. It doesn't say AUFS, but it has to. We'll find it, by the way. We'll find another way where it will actually describe the underlying underlying file system. It is, by the way, this is one of them. There are a couple of choices available in layered file systems. One of them is AUFS, which is, I think, what Docker installs by default, but I'll just cross-check. So you understood the idea of layering, which is, I just gave you a very, very trivial, simple example, but I'll elaborate on that just a minute. I want to erase my illustrations now. And go to a browser window where I can do a Google search. What do I want to search on? AUFS. And here is your name of the thing called AUFS, which is another union file system or advanced multi-layer unification file system, or make up your name. But that's a Linux file system that is used under the hood as an overlay. There's a merging overlay file system. Overlay FS is merged into Linux kernel. I think there is some changes here. Apparently, let's go read. So I'll go to Docker website and Docker overlay file system. Overlay file system. Let's see what they use today. And the storage driver being used is called apparently they are using overlay. That's the name of the overlay FS is the file system they're using. It is similar to AUFS. So there is a change here. The change is that I remember they used to use AUFS, but apparently they're now using overlay FS, which is fine. Just want you to know and take a note, like right there. It is similar to AUFS, but faster, simpler implementation. And that's the original overlay, and the newer, more stable overlay 2 is the overlay file system. And that's what you are looking at. So that's what you got installed. That's what you have in our 2 cloud locations. So under the hood, what is this overlay FS storage driver doing? Let's go find that out, that piece out. So I'm going to clear this drawing and go back to our machines there. So that's what they're telling us, is they're not using AUFS, but apparently they're switched over to this driver, which is overlay 2, which is fine with me. I don't care as long as it's an overlay layered file system driver. And so that's what they have changed, which is doesn't matter. Whatever the underlying concept remains the same, is that it is a layered file system. And why does it matter? That's the key thing to remember and understand. So I'm going to again get to a clean sheet of paper where I can find it. Hello, clean sheet, where are you? Maybe that's a good sheet. I'll use this and draw. And what I will draw now is a little bit wider Linux box, which gives me Linux. It gives me the underlying ext file system, gives me a kernel, and all that good stuff. So that's the machine. The machine, it gives me some CPU, memory, disk, network, like that. All the basic capabilities it provides to me from the bottom up. And then I have containers. They're completely isolated from each other, and they are just containers. Now what I want to be able to create is have this container become a LAMP stack. So I can do that simply by saying, you know what, Apache, PHP, MySQL. And once I have that, what I can do is, create one more layer to install WordPress, and then this becomes a WordPress container. So I can then serve WordPress. That's the conceptual idea. But the beauty where overlay file system comes into play, the file system like AUFS or overlay FS, all these are overlay FS, these are all layered file systems that look like this. So it becomes my WordPress container right here. And all I did was appropriately select my layers I need, and then add my application on top, and boom, I serve. And I'm able to serve my customers with what they wanted, WordPress. Tomorrow, a new customer comes along and says, I want Drupal. So what do I do? Do I put more layers like this? Is that the idea? Well, let me tell you, that is not the idea. So how do I optimize? So the idea of optimization comes from the idea that you should reuse what you already have. Which means I have an Apache layer. Why not I just draw it like this and extend maybe like this, and maybe extend this layer like that, and then divide, of course, isolate, isolate, isolate. And so this is Apache, this is Apache, this is Apache, this is your PHP, this is your PHP, this is your MySQL. And so this Drupal customer comes along, and so you want to have WordPress installed for this container. So you have it there. And these guys do not want WordPress, they want Drupal. So you want to install Drupal here. And so you read what the requirements of Drupal are. And apparently it is the same LAMP stack. So you have the LAMP stack already now. You just put a different layer on top of this. You're reusing the existing Apache here. And we will do actual examples to illustrate these concepts, by the way. So don't worry about that piece. I'm just telling you the ideas at the top level to understand layered file system first. So now, tomorrow, this Drupal customer that you have says, you know what? I don't like MySQL database. I would like you to use a different database we know of. It's very good. That's what the customer tells you. So what do? The customer says, yeah, don't use MySQL. I want to use PostgreSQL. So what do? You come down and you say that I don't want to use the MySQL layer. So you, oops, I erased it by mistake. So MySQL WordPress, yeah, leave it like that. And I want to now put a new layer. It is the PostgreSQL layer, and install Drupal on top. It uses the underlying Apache and PHP, but it doesn't use the MySQL, instead uses PostgreSQL and puts Drupal. And my customer is suddenly happy because they wanted me to use Postgres. So I gave them exactly what they want. At the same time, not focusing on anything else, just the customer. And that's the underlying idea. You got Drupal, you got whatever you wanted. So the customer is happy here, the customer is happy here. Both of them are happy. And I am also happy because you know what? I'm still paying only $5 to the machine. And they are both running comfortably with their databases of choice and applications of choice on the same machine in separate containers. Got LAMP stack, LAPP stack, Linux, Apache, Postgres, PHP, LAPP, whatever. The acronyms are BS. Erase them from your mind. They're basically made up words. So people will come up with LAMP stack, WAMP stack, Windows Apache, MySQL, PHP, Macintosh Apache, MySQL, PHP. Sometimes people will come with mean stack. That means this mean stack means a MongoDB, Express Server, Angular, and Node.js. So people will just come up with random things to confuse everybody else, but they are all meaningless to me. This is not how you should actually talk about. You should focus only on one thing in life, in business, and that is your customer. So whatever they tell you, whatever they want is what you build. Everything else is pointless. That's the idea of business. So we do exactly what they tell me, and we do that, and we give it to them. They happy, we happy, everybody's done. That's the focus. So that's the underlying idea behind layered file system. Now tomorrow you have another application there that says, you know what? I would like to have an application which gives me Apache server, but Python language, and I want to run Django as my application's platform, and I'll create a custom application. That's this scenario. So I want Apache, by the way, and this is the container where I want to run Python language and Django framework and custom application. So I said, you know what? I got Apache already, so I'll use it. I want to install Python. I'll create a new layer called Python. You want Django? I will put Django on top. And now you want a custom application. You throw it on top here, and you are happy. This customer says, I want to run a Ruby on Rails application. So I'll say, okay, Ruby on Rails. So I will bring my eraser and say, you know what? This P should go away. Instead, separate layer, running Ruby, then on Rails. And now you got Apache, Ruby, Rails, and your custom application running Ruby on Rails. So you put that application on top in a separate layer, raw app, custom app. And then this customer also becomes happy. They also are happy. That's the goal. So what you're looking at is this structure of creating different layers is allows you to reuse things without having to install them again and again. At the same time, you are to remember one thing. is that it gives you complete isolation from each other, but allows you reuse. That's the idea of a layered file system. So basically reuse whatever you can. Don't have to worry about fetching new things, setting them up. It just happens, and you will see when you see it live, you will actually understand and appreciate what's going on. So with this discussion, if you have any questions at any time, just stop me, but I will now erase unless you ask a question, in which case I'll answer that first before I erase. But I do want to erase so I can move on. So I'm going to erase now. And we go to the next idea, which is, where is that sheet? Here. So we discussed the idea of an overlay file system. We discussed C groups to regulate limits on what we have. We discussed kernel, and we did not do these things yet. No. So now let us quickly look at this thing. It's not actually super interesting, but just a place for us to know that that's where Docker keeps stuff. So let's go there and figure out what that thing is by looking at the command line and saying, in one of the two machines we have, we'll say hello, and we'll go to var lib docker, and you will find there is something here. And so this is the place where Docker will store its own stuff. I don't recommend you going there and mucking around, because that's not the idea. But I want you to know that this is the folder location, docker var lib docker, where Docker stores its own stuff. Images, network, overlay, plugins, all these things. That's the store. If you erase this folder, you're screwed. So don't, but you can, because you ruled. So you can actually delete the whole thing, but don't. Just want you to know that that's the folder. That's where it stores stuff. Okay, next idea. Where is that? Here. So that was the concept behind the place where it stores stuff, all these things here. So we discussed this, What is remaining? Let's go focus on the remaining ones. Okay, we have to talk about volume, network, and registry. Okay, so we'll talk about volume now. How do we do that? Okay, it's an example. So let us talk about some volume ideas. Volume. So let me simplify these things. Let me just cut that short and simplify the concept quickly. I will erase the red ink, and before I do that, I'll just make a short list of things that we still want to keep discussing, and those are these 4 things at the bottom. And so everything else we have discussed, which is cool. So I'll erase now. I will focus on these 4 things. Let's go begin with volume. So what is volume? If you know what a volume is, please go ahead and tell me that you do, so I don't waste time on this. By the way, I just want to caution you, there is so much stuff in this bootcamp that I may not be able to cover all of it. We don't have much time. So, but don't worry, you have access to it, and you have access to me. Even if the bootcamp time runs out, doesn't matter. I want you to focus on getting what you want to get. So focus just on that, not on whatever else out there on the planet. The planet is too big, and there are just too many things to discuss. So focus on what is relevant to you, and focus on what is important to you, and just do that. That's the best way to handle any new thing that you're dealing with your life. So now volume, that's the idea. If you know what a volume is, please tell me. Otherwise, here it goes. Volume is disk. Volume is folder. Volume is a place to store stuff. Volume is storage. That's what volume basically means in the context of Docker. And I said, you have a machine and you have containers here, and I told you that they don't share anything among each other or with the machine here. So the underlying machine running some kernel, the Linux machine. And it has some file system, like extfs, for example. That file system is there with Linux. You already know that. And so what we want to talk about is that we know that these guys don't share anything with each other. Nothing shared. But what if you want to share? What if you have a folder here called home Nilesh and then XYZ, and you want to share this folder with this container? So how do you do that? You want to do it. So you have to explicitly tell this container that I am going to give you access to this folder in this machine. So please take it. And not only take it, but you also have the ability to write to it. So this is the reading ability. This is the writing capability. You can read and write. As long as you are within the boundary of this folder, you are okay to read and write. So that is what we have to enable for this little container with a volume mapping. So that this poor little container can read and write to this actual folder in the actual machine out there. That relationship is called a volume mapping. That is what I am going to build live. It's an example for you. So we have this folder here called home Nilesh. It's in the Azure cloud, by the way. And so we'll go to the Azure machine and do exactly what I just showed you, which means I'm going to erase the red ink now. So red ink goes away. Gone. I will now go to the Azure cloud somewhere here. Where are you? Here. So this is your Azure cloud. And let us go find out what we got there. Yeah. So here in the Azure cloud, do we have any Docker containers running? No. By the way, I will just type commands randomly, and that might throw some people off as to what's going on. I'll just speak in English and write in command line. That might happen, and it might increasingly happen. But don't worry about it. All I'm saying is that these commands there will be too much of these things, by the way, coming along. Like this command, that command, they're all documented very, very nicely in various places on the internet for whatever product we'll be discussing. These things are written down. You don't have to memorize anything. That's the whole point. All you need to really think about is take notes on a cheat sheet for yourself. That is going to be your cheat sheet of how you think or what you think is important. I think that's what you should build. A cheat sheet of things that you're interested in, and just keep note of whatever I am doing, and you can find these answers to your questions on the internet by just Googling them. If you don't find it, ping me, I'll give you the answer. If I don't find it, we'll Google together. That's the idea. And so if I don't know the answer, I'll Google for you, or we'll go find out the answer somehow. We'll get to the answers. But I will probably do things like I just did. I said, do we have any Docker containers running? And answer is no. So I am not even describing the command, because I expect you to take note of this and understand the meaning behind what I'm doing with what I'm actually typing. They may be a little bit different. Like I said, are there any containers running? So the command happens to be docker ps-a, and I seem to have memorized this, but memorization is the wrong way to dealing with things. So don't memorize anything. Like, do not at all, but understand the concept. That's the only thing you should actually focus on, is concept. So I'm checking whether I have any containers running, and what I want to do is actually to create a container, right? So there will be a method of creating a container with a volume mapping. So I have a folder here. The folder is called home Nilesh, and I want to create a new folder here called XYZ. and I want to give that folder out to the container, this folder, right? So that folder that I have called XYZ, I want to give that folder access to a newly created container that will pop up right here in the list. That becomes a new container, and that's what I want to really do. What I am trying to accomplish is the idea that I just described to you in terms of volume mapping, which means, like usual, even I don't remember everything and anything at a given time. So I need to now Google. What do I Google? Is how do you do a volume mapping in Docker? So here's how you Google. So you say Docker volume mapping, boom, and it will pop up with the right answer right there. And here is the idea of running something that you want to do a Docker volume create, like this. Yeah, that's a good one. Good example. I'll copy this from here, and it's doing something for me. So I'm just opening it up, copying it, and I'll explain what I'm doing. By the way, I just copied some ready-made example. I can run it now and go to this. And here I will open up a note sheet where I will paste that command and then discuss this thing. Like, what is this thing? So this is a command to create a Docker container and run it with a name called Cloud Genius. And it does a volume mapping to that location. And it maps my folder called home Nilesh XYZ. And it creates a new container running the latest version of Nginx container image. I think there was too much detail here, so I will simplify this. Let's go simplify item by item. What I'm doing here is running a command to run a Docker container. That's the first portion. The next portion is that I am line number 6. I'm saying that you please run that container like a daemon, like a perpetually running service. I should not say service, like a perpetually running container that doesn't exit, doesn't die. It just keeps on doing whatever it's doing. For example, this container is Nginx. So it will keep on serving whatever it is serving perpetually. That's the underlying idea. Perpetuity is in line number 6, -D option. It will keep on doing this thing until you go and kill it, kill the container, which I will kill, by the way. But that's the underlying concept. I am going to give it a name, like line number 7. Maybe I'll make it a shorter name as opposed to that long name. I'll just call it CG. You can call it whatever you like. It doesn't matter. That's the name. Then I'm doing a volume mapping. And you see the volume mapping right there in line number 8. And let's go see how carefully we can understand this idea. So the idea is volume mapping. Let's see what's going on. What we are saying is do a volume mapping, dear Docker, when you run this image. Do a volume mapping for me, and that's the -V flag. It tells you to map this volume from the real computer to this volume or to that location in the container. This is the real one. This is the container location. So now let us focus on this line number 8 one more time. And look very carefully what's going on. That is the idea of volume mapping. And I will make it a little bigger. And you should watch carefully the parts of this line number 8. So there is a colon there. There is a -V flag. And then there are these segments. And the other segment. This portion belongs to that location inside the container. And this portion belongs to that location inside the machine. By the way, I just created this folder called XYZ, as you know. You saw me do that. And so I will now clear this red ink going away, and I will copy this command like that. It's a multi-line command. You see I have trailing slashes, which is a good sign. I will copy this command and take it to my command line. And here I'm not dealing with DigitalOcean because that doesn't have that folder called line number 8. I'm going to deal with the Azure Cloud right now in this example. And so here is my Azure Cloud. I have that folder there. It is called XYZ. And that's the folder I'm talking about. Sorry, this folder is what I'm talking about, PWD. That's one I'm talking about. Let me come out of that. And I want to run this command right here. And what this will do is, as I said already, it will run a Nginx container with a perpetuity, username CG, and have a volume mapping. So let's go run it. So I run it and it says I'm not able to find this image locally. So it will go to the registry. That's the idea of registry. So here we go. Let's go look at our registry. We'll go into the registry to fetch an image called Nginx, because it cannot find this image Nginx colon latest. That image was not available locally. So it went to the registry and fetched the image. So the image came down. That's an image, not a container, an image of this software in its latest version. That image was not available locally, so it fetched from the registry. A very well-known registry is hub.docker.com. You should create an account there. Yeah, just open an account, just like GitHub. This is Docker Hub. Open a free account and enjoy. The idea of enjoyment comes from the fact that you can, fetch any image that you want available from that location, this location. Not only that, these guys let you push images, your images, to that location. So tomorrow, why tomorrow? Today we will create an image and we will push it to this location so that other people in the team can fetch the image and use it. You can see that action right now. This Docker Hub operates conceptually like GitHub, not exactly like GitHub, but more or less kind of, so that's the concept. You create, you push, somebody will fetch, things like that. So that's what you're looking at in the registry. There are many registries. This is just one of the very well-known ones, and it's officially hosted by Docker themselves. So that's what most people apparently use, but you're free to use. Every cloud will give you a registry, like Azure Cloud will give you ACR, Google Cloud will give you GCR, Amazon Cloud will give you Amazon registry. So everybody and their brother have their own registries, but you can have your own also. It's very easy to run a registry. So you can actually run your own registry. It takes one line command and you have your own registry in some machine somewhere that you like. That becomes your registry because there is a image called registry. And what you need to really do is just run the registry image, just like we are now running the Nginx image. If you run the registry image, you get a registry, as simple as that. But that's about registry. So we just discussed that briefly. I'm going to clear my red ink. By the way, create an account on hub.docker.com for yourself. Please do that. We'll be creating an image and we'll be pushing to it soon. As soon as we get to that point. So let's now look at what did we run. So we begin here. So let me just quickly check one thing. Yeah, annotations. So I'm going to write on the screen now and look at what we did. So we'll understand and then figure out what's going on. We said, Docker, please run perpetually Nginx latest version. So it is not able to find this image Nginx latest version, so cannot find it locally. So I'm going to pull it meaning fetch the image from the registry. The name of the image is library in Nginx, library Nginx colon latest. That's the name, colon latest. I did not write clearly, so I'll erase this. And you know the name already, so I'm just not causing any confusion. The name is this from the library location, which is hub.docker.com, hub.docker.com. That's the library location where it fetches from. And that's the fetch action pulling, and then 1, 2, 3, pull completes. Once you pull, you get a SHA image. That SHA is a digest for the image here. The Nginx image is uniquely identified by that SHA, that hash here, for the whole thing actually. That is the digest for the image that was fetched from this location. That's what you wanted. That's what you have now. The Nginx image pulled because it was not available locally. So it was fetched. Now, let us see the volume mapping. So we expected a name, this name, and we expected a volume mapping. So let's go see what do we have inside that container. So what I will do now is erase my annotations and focus on what do we have running in Docker. So that's the thing we have running in Docker. So what do we find? We find that we have a image used called Nginx latest, and we have a new container running by that number. The container has a name called CG. That's the name we used. It is running for the last 5 minutes. It is up and running. It is exposed port number 80 within the container. That doesn't mean that you can open up Firefox browser. It doesn't mean that you can successfully open the browser and see that port 80. That's not what it means. If you go to localhost, what will you see is what the machine is showing you, which happens to be the wrong machine, by the way. We are not on that machine. This is the Azure machine. So we need to go to that location. What's the IP address of that? That location, if you go, you will find there is nothing. And there we go on that location. Oops, copy properly, like that, copy, and then go to that location, paste, and hit, and you will find unable to connect, because that machine is not running anything. Even though our container is running Nginx and it is exposing on port number 80, it is not actually exposing at the machine level. This is the machine. So you'll see unable to connect because there is nothing on the machine itself. As you heard me say before, the machine is separate from the containers, and containers is running Nginx, and it is exposing its port number 80 to the other containers. That's how this container is designed, is to expose. This is by design for that Nginx container, which is the image that we are using, and the container name, and there is a container ID also. So as you know already. So I'm going to erase these illustrations again and help us focus on our volume mapping first. And then we talk about this port number 80 also. That's the network parts in our discussions, which is what we will soon discuss, network part. But right now, volumes. So go back here, volume mapping. In our container, number is 5ccd, whatever that number is, the container ID. For this image that we have downloaded, let's see how many Docker images we have. And we have, oh, we are on the wrong machine again. I think I quit for some reason. I need to go back to the machine. So I'll say SSH, go back to my Azure machine. This is the machine called whatever in the Azure cloud. And there I have Docker ps-a. And there I am running this machine, this container called CG with that identifier, and I have Docker images stored locally now. One of them here is now locally available. That's the image identifier. It is created 13 days ago by somebody called the Nginx developers. Its size is 109 MB. That's the image downloaded from Docker Hub. I'm using this image to create this container here. The name is CG, and I have a volume mapping. I want to explore the volume mapping. Basically, what I want to do is to go to this folder XYZ, and there I have nothing, right? So I will here create something. Type something. There it is, my something now, right? I have a file there. You saw that, I created it. But I want to now enter the container. That's the new concept. What I want to go is, I have this machine, which I am connected to right here. And I have a container running here with port number 80 exposed. And apparently I have a volume mapping called that location, which maps to this location. That's the relationship I apparently created. But I want to prove it to you that that's how it is established. Some location called that location inside this container running Nginx is where you should see this file that I have created here called something. I just created that file, by the way, this file. It's an empty file, but it's there. This file should be available to this location called that location inside the container. But I am connected here. How do I go there? I need to connect from this, sorry, I'm actually here, and I got connected to Azure Cloud. And I want to go here, and I know it is completely isolated. The only connection we have is this, which is a volume mapping. But I want to actually make an SSH connection. Well, too bad there is not a possibility, because there is no absolute no connection between this container and anything else. Not allowed. But Docker gives you a method to connect, which is not SSH connection. Docker gives you a shell in this location. So that's what I will be now showing it to you. I want to go to this container ID and ask Docker to give me a bash prompt on that container. So that's what I would like to see. This prompt is currently in my whatever machine in the Azure cloud. I want to get to a bash prompt in this container inside that machine. That's what I want to go. I want to go from here and say, you know what? Yeah, make me go there. That's the idea I'm doing now. So I'll erase my red ink and then ask Docker to help me go to a new command line. This is not strictly not necessary, but I'm just, for the point of illustration, just showing you a separate command line, which is SSH. What's the machine IP address again? There on the command, I see it there. So it is SSH Nilesh at 40.112.161.252. So I am back to Azure Cloud from a different shell, this shell. And this I kept it deliberately separate just to not cause any confusion. So we have that on the right side, Azure shell, and we are going to now go inside the Docker container called file Charlie Charlie, that number, file Charlie Charlie. I want to go inside there. I'll say Docker, show me what you got. So they have this file Charlie Charlie there, and I want to connect to it. So I'll say, Docker, please let me connect to that container and give me a bash prompt in there. So it connects and gives me a bash prompt. Let's go see what we have. What did I do? I said, Docker, execute a shell in this container and run bash and let me interact with it like a teletypewriter mode, TTY. That's what you have, a different machine, not the Nilesh user, but root user, because Docker runs in root. And this is the container, which is this same container, which is the same container. So I am now inside the container. And if you remember how I started that container, it was a Docker run command. We have it on our notepad somewhere. I'll bring it up also. So let me erase my red ink again. And I will now bring up the command that I used to create it, which is this one right here. So I made a volume mapping and I want to test it. So I am now inside this machine called sorry, I should not call it machine. I'm inside that container called Phi Charlie Charlie, also known as Cloud Genius or CG. That's the short name for it that I created right there. And what I want to do is go to that location called that location inside the container, right? So I want to go in, I'm inside the container here. I want to go to that location and find out what do I have. I apparently have a location called that location inside the container. So I will go inside that location called that location. And there I find something. What do I find? Something, because that's what I created, this something. So now I go to that location and I find this something which was created on October 30th at 0040. October 30th, 0040. Okay, what I will do now is I will edit that file called something. And here I will cat that file called something. You see that it contains nothing, which is fine. But I want to put some item in this and then save it. So I edited this file called something. And now I have some item in this. So now I will like to cat that file in the container and I see that item. So it is the same file with a volume mapping as shown in line number 8. I want to go and maybe delete that something. And then that something disappears from here. And I will now create another thing. And that another thing shows up here. And I delete the another thing. And the another thing is missing. Because that's what it's supposed to do. That's the volume mapping. Questions are welcome. You guys are silent. Either you're not listening, or I am super boring, or one of these two. Or maybe I was super clear and that you understood everything, which is awesome, but I don't believe it. So questions are welcome.
Hey, Nilesh, I just wanted to say I'm following along. So everything's good for me.
Thank you. Good to hear. That's exactly the affirmation I want, is that I want you to really understand. That's the only thing I want to in the program, is really make sure that you understand these things. So
yeah, awesome.
Thank you, sir. Thank you very much. Good to hear that. That's your volume mapping, right? You can map anything to anything, from the actual machine to any container. You can do other types of mapping also. We'll talk about that volume mapping in a slightly broader context, and I'll maybe give you a hint so that you will start to think in that direction. The ideal, or rather most commonly way that this mapping is actually used is to store stuff, right? That's the whole point. So you have applications storing stuff in various places. So what we want to be able to do is like this. You have a container running here, another container here, another container here, and they may be on machine number 1, machine number 2, machine number 1. Who knows? Some container running some machines. So you have like, you might have like M machines and running N containers, right? These containers will run on some number of machines, any number of them. Like these, N is typically more than M, but not strictly necessary. You don't have to run a container. You can have an idle machine doing nothing. That's all possibility. And 0 containers, that's a possibility. But the typical scenario is, one machine will have multiple containers. That's the commonly deployed scenario. So what you want to be able to do is retain the ability to kill the cow whenever you want. And you know what cows are? These guys. You want to kill the cow anytime you feel like. Not all of them at the same time, but one at a time. You want to be able to kill so that you move on and maybe get a new thing. We're still running containers, and you want to actually, not even worry about these cows, because all you really care about is these containers. And you can have, CA, CB, CC, like that, multiple containers running, and wherever they are, whichever cloud they run on. Maybe some are repeated, some are not. It's your design, your implementation, but you want to basically pull the rug under the hood. Like, if a application is running, you under the hood want to remove M2 and have this container, boom, switch over to another machine. That scenarios are possible now that we have such a flexibility. And to retain that ability to kill this cow and have this machine go to M4, or maybe go back to M1, or this container you want to move from here to there, or machine number 37, or whatever you choose. Or maybe tomorrow you decide that this container needs to go none of these places, but a new machine you create here, M35. And so this container needs to go run here. That's totally fine with us. All you need to really focus on is no data is lost. But you want to kill the cows left and right whenever you feel like, and grow the cows and shrink them and all that good stuff. So you want to store your stuff out of this mess somewhere else. So there are a couple of places you can store stuff. For example, external file systems. And there are various examples. You heard me say that in Azure Cloud gives you Azure files. In Amazon Cloud, you get Elastic files, Elastic file system. And like that, you can create your own cloud solution for storage, like NFS server on your own. So you basically use these solutions to store stuff. And you want to create a container that maps to an NFS mount directly. And the idea of NFS is the best one, is that it allows multiple containers to simultaneously connect to and read and write, with the ability to lock. Whenever somebody's writing, you lock everybody else. And then when they're done writing, you release the lock and let everybody use and reuse. The idea of a shared file system that is inherently capable, provided in the best possible solution is right there. It is open source. And it is available to you in Linux by native. Linux gives you that. So it's there, use it. For this to succeed, you need to create an external file system that stores files for your containers, wherever they run, on whichever machines they run. The containers will directly mount a volume from a network storage location. Now here is a live example. you are now looking at my Macintosh. And in there, you are now looking at some of the, let's see, is this machine or not? Let me just quickly check where the things are running. Yeah, there is no Docker here. So let me get to another machine where the Docker container is running. And that is where I have one container running. So this is just some machine, right? Somewhere in my home. Apparently this container is called the container ID. The name is Mini. And what's the point of this? The point is that this container runs. Do you know what this thing is? The thing called Plex Incorporated PMS Docker FlexPass. If you know what this thing is, please tell me that you do. But it's not important. It is some image. You know, if you really want to know, it is actually a media server that I am running here, which is how I watch TV. Actually, I don't, but this is how people in my home watch TV. Is like this. It gets you watch live TV and everything. And this is, by the way, coming straight from a container. You can watch the local public television like clicking that. That's the idea. And so I'm going to stop it, but that's the point. So this is, you know, live TV antenna recording, showing, playing, doing all that stuff is called Plex. But when I record a program, if I want to record something like this King 5 news showing right now, I start it, I record it like that. And I record, and it just click the record button, it will start recording. And this Lori Matsukawa, this lady will, with the recording will appear, but where does it go? It is not going to be on that mini container, but instead it will go on a network storage. Let's go see how did I create this container. So that just give you an idea about how in real life you will use it. So here is the underlying Docker compose file where I have something like a volume mapping. So let's go see the volume mapping now in real example context. So this was a line number 8 was a trivial toy example. So this is more complete example of what can you do with a volume mapping. So what you see here in this live example, which I extracted from, is this is how I actually watch live television. And so I have this NFS server running here. I'm saying no lock. This is just how I want to avoid locking. I'm letting disconnections happen whenever I don't want an established persistent connection. So it is soft in that the disconnection of, sorry, let me discuss this later. Just don't focus on this one. No lock is the idea that, you know, there's only one person using, so no need to lock and release. So nobody else uses that network storage. This is a NFS storage in that server with this IP address and read write. So that other mini MINI, that container that you saw running, is actually connecting on the fly to this IP address, uses the NFS server with no locks and read and write, and it mounts itself at that location. And that's the location where I am storing all the content that this TV recorder records. Whatever you record here just dumps in that folder in this machine. So it's an actual separate machine. This is my network file system solution for my home usage, which is, you know, my pictures, movies, music, TV shows, bunch of other stuff, you know, family videos, they're all stored in this location. And I am mounting a Docker container on NFS mount. This is not a common, this is not how people do in most homes. You will not find it. So this is how enterprise uses it, by the way. So most businesses will use it this way. In homes, you will never find such a thing. Maybe rarely, you know, maybe very few people actually do these things in the homes. But let's understand what's the enterprise use case is, that you have some container. I call it the mini container. It needs media. The media is stored here. Media means music, video, TV shows, this and that. Files, large files. This is a very large 17 terabyte storage. So big box right there. And this is the IP address for the box. And it uses the NFS mount point from this container to this location. And it reads and writes. So I can get rid of this and create a new one anytime I feel like. That's the concept. That's the underlying idea I want you to take away from volume ideas. So this idea is a trivial volume mapping directly from the underlying machine to something inside. This is a network volume mapping, NFS. Does that clarify? Does that relate to the concept that I'm talking about in terms of volume? This is NFS mount. Straight from the container onto some NFS server. Does that clarify something at least? You will see more live examples later on, but does this give you an idea about what volume mapping is? I hope it does, but I'll cross-check at later time. So that's the NFS mounting method. And I'll describe this method in a little bit detailed example later on. Let's focus on this simpler idea first. So you saw that. And if you now go back to the command line here, and where is that? Yeah, XYZ. Oops, what did I do? Bring it back. There we go. And yeah, this one. Okay. Let's just delete that container. Like, you know, I have this thing called XYZ, which contains nothing right now. I'll create something else in there. Oops, not create is not the right command. Touch something else. So I created that something else, and I go and check it out in the container, and I have that something else. But let us now look at the other idea in volume mapping, which is called persistence, persisting the data. So what does that mean? If I am somehow able to destroy the container, so I have this container running, and I decide to kill it. So I just kill it. The container is dead. This 5C is a representation, a short representation of the 5 Charlie Charlie Bravo 7 Delta 7A, that whatever that number is. This is a short representation of the same number. And I just killed the container, which means I don't have any more. Which means, ouch, did I lose the data? Not really. I still have it. What if I want to get that file back and my container back? What do I do? Well, I run this again. I copy and I run it one more time. Like here. In my machine called whatever in the Azure cloud, I say, okay, you run it again. So you now have a container. This time the image was already there locally. So it did not pull the image, and I have a new container running already. And I can just execute into it. And you see the number is changed this time. It is 5.2 as opposed to 5 Charlie. 5.2, that number. And in that number is 5.2 echo 5, that number. Is what I'm going to do is give me a bash prompt, please. So it gives me a typo, bash prompt, please. And so I get a bash prompt. And there I go to that location, and I find my something else, and I delete the something else, and it is gone from here. And that's the concept. The file is there unless you delete it, but the storage doesn't disappear. Storage location exists, and you can have something useful there, and you can see it. And you can see it, and you can, of course, come out of that executed inside the container, come out of that and check out your running containers, and it is running just fine. The container has access to that location, which is the volume mapping, line number 8. So that's the underlying concept of volume relationships. That's line number 20. So we discussed that. We'll move it here. Line number 20, move it here. And now we'll discuss with registry, we discussed that. We'll talk about networks now. Networks. And there is another thing called Kubernetes, which is not in that list. So we'll discuss that, but these two we'll discuss later. They're very, very complex by itself. So we'll have to do a bunch of exercises before we get to line number 23 and 24. But for right now, networks. Let's understand that piece. What I want to find out is this thing that is running Nginx, and it tells me that it is running Nginx, but it shows me that this port number 80 is kind of there, but it doesn't tell me how do I access that port. That port is unable to connect, and that is rightfully not able to connect because it is supposed to be logged out, supposed to be unable to be accessed unless you explicitly allow it to be accessible. But we haven't yet. Therefore, this port is open only within the container infrastructure, and you cannot go there, literally. So there is a machine which is, there is a port number 80, which is open, by the way. I can go there and see because I opened port 80, port 443, port 22 and all that. At the time of creation of that machine, I opened these ports up. So it is open, but there's nothing running here to show me. So it doesn't show me and says unable to connect. This guy doesn't see anything. But now I want to see whatever I have here in the container running Nginx, and it shows me at port number 80 at the container level. So I want to do another mapping of sorts, another mapping of this port with this port. That's the mapping I want to do, like pretty much like this. Just like we did a mapping on file system, like that location with this folder XYZ here, we did a mapping. That was volume mapping. I want to do a network mapping. So which means I need to delete this container and create it again, because I did not create it with the focus on creating this volume network mapping to begin with. So creating a container, deleting a container is like trivially simple things to do. So as long as you have your data intact and stored somewhere else, you're okay to delete that container. So we'll get rid of it. So how do you delete a container? You just say rm or something like that, some command. You can always figure it out how to delete a container. Do a Google search, you will find it. Like for example, here, how to delete a container. So it will tell you exactly how to delete that. Especially focus on official documentation. So click there, and there's the command usage. So you can read that or take your own notes if you like. But I know that my image number, rather, my container ID is 52E5. So I'll just say docker rm and then 52, and it dies. The container is dead. But what I want to really do is just like this volume mapping, I want to do a port mapping. Like that. That's the idea. Line number 9. What you're looking at here is a way to map a port with the container inside. So this is your machine port. This is the container port. and you want to do a port mapping. -P option. So let's go run it and see what happens. So I'm clearing my ink, copying this, and going to the container. Sorry, going to the terminal where I have two terminals connected to the same Azure cloud. You see I have this XYZ folder containing something useful, but that's not the point today. The point right now is, do I have any Docker containers? And I don't. So I need to create one. So I go and create one, and it gets created. Now I see, what do I have? What containers do I have? And it tells me I have something. And this look is kind of different than before. Earlier, all it says was 80 TCP. But now it is telling us something different. What's it telling us? Let's find out. Earlier, this look and feel of this thing was this. Before I put a volume mapping, port mapping like this, which is a new command. This -P reference leads us to this port mapping. But what does it mean? How do you read it? It means 0000 means anybody on the internet that is able to come on to the port number 80 at the machine gets redirected to port number 80 inside the container. That's what it means. See the redirection symbol. There is a redirection symbol like this. Anybody on the internet who reaches the machine at port number 80, like this guy, will be redirected to port number 80 in the container. That's exactly what we want. That's what we want here, because when I hit this refresh on this port on this browser, it will go from this location, or my location, to that port on the actual Azure machine. And it will get redirected to the port number 80 inside the container where we know it is running Nginx. So what does this do? When I hit refresh, you can tell. I'm going to clear my ink. And then go to the browser and say, try again. That was obvious that it would happen. That is because of this line. Port mapping, which is a network concept. Machine port, container port, map. This is volume mapping, port mapping. That's the idea. So let's play with a little bit more. What if I want to not use this port, but maybe use some other port, like for example, 81. Maybe this exercise, it will not work in the Azure cloud because Azure is limited. They don't allow us to open these ports, so it will not work. What I was going to do is random exercises on the fly, make stuff up, and just mess around. That's my idea of working. So I want to do that, but Azure is limited in port number 80, 443, 22, and 3360. I don't. Some couple ports are open. Not others are not openable easily. At least at the time of creation of this machine, we did not customize the port sequence. So I don't want to mess with that. I would just go to an easier cloud. An easier cloud is a cloud that doesn't put too much limitations, which means it will let you do whatever you feel like, which means it is risky if you don't know what you're doing, which means it is insecure if you don't know what you're doing. And therefore, it can also mean that it is considered as a cheapo solution, but that's fine. But I actually like the cheaponess of this because it gives me the ability to do whatever the heck I want. And that's where I am now, switching over to DigitalOcean to experiment with crazy ideas that I come to my mind. Like, for example, I'll use the port number 81 for no good reason. So I will now switch away from the whatever machine and go to the other machine. What is my other machine IP address? It is here. So I'll grab that IP address and connect to it. I will also get rid of this command line and connect to the DigitalOcean machine, which is where it lets me experiment with whatever I desire. So there's no limitations there. They let me get root access, and basically lets me do whatever the heck I want. That's what I like about it. It is not the best solution, by the way, for production deployments. I just want to caution that this is not how you actually run your customer's business. You can if you know what you're doing. There's nothing wrong with using these clouds. But just wanted to point out, they are not going to spoon feed you. They let you create havoc and mistakes, and they don't even prevent you from making a mistake, because they're basically designed for people who know what they're doing and not for kids. But that's the reason why we go there. So because it lets us understand and learn a lot better. So I'll now experiment with the same ideas before, but with craziness included. For example, I want to run this 81 port on the real machine. Can I do this? Absolutely yes. Let's go figure out how do you run it. So I'll take the same command and make a volume mapping different. So like my folder is root and there is no Nilesh there. So I'll get rid of Nilesh, and I still have that location. Maybe I'll call it something else, whatever is a good name. So what? That's my name. And here is the volume mapping and port mapping together. I'll copy now, and I will go to DigitalOcean in 2 windows. So 1 window, I need to create a folder called root XYZ. So there I have it now, called a folder called XYZ. And on the other window, here in DigitalOcean, I'm going to create a new container with the understanding that I have a folder called XYZ in root. That I want to map to what? Folder. And do a port mapping between port 81 and 80, which means I should execute this. And I don't have the Nginx image locally available in DigitalOcean Cloud on that box. So unable to find the image locally, is going to pull it down from Docker Hub, and then we are done. So let's see what do we have. We have a container running. The container has a volume mapping and a port mapping with crazy ideas in place. 81 mapping to 80. This is my crazy idea. I just want to have it. So I did it just to illustrate the point that you can do whatever you feel like, literally whatever you feel like, even if it is non-standard. Because nobody else dictates but your customer. So if they want 81 port, you just give it to them. And so I want to grab my IP address again quickly. So I will grab my IP like that. And then try to open up a new browser window with that IP address and try to hit it. And you will find nothing, unable to connect. But didn't you just run something there? Why is it not connecting? Do you know what's going on? Do you know what is going on with why is it unable to connect when I just ran something? Can you tell me? When I go to this IP address 104 dot whatever that IP address for DigitalOcean is, I go to that IP address http:// I still see unable to connect, and that's the right thing to see. But why? The answer is right here. I will now erase my ink and go to the right location where I expect it to be. I am expected to be not at port number 80, but at port number ouch, but not at port number 80, but at port number 81. That's what I'm expected to be visiting. That's the crazy idea part here. So I expect to visit this site because that's what I wanted to see. On port number 81, what does it show? That's where it should show me Nginx, not this. And this is the default, by the way. This is the default port number 80 is what everybody uses. That's the HTTP definition. But I want to do something weird, which is to go port 81 because I can. And so here we go. See it now. You will now go to port number 81 like that. And you will see Nginx. Because that's what we did. I mean, that's how it works. Like, that's how we set it out to be, to begin with. And therefore, you see what you see when you go to a non-standard port, :81. The standard port, which is basically silent, that goes to :80. When you don't write anything after that number, the IP address, we don't write anything, it goes to this number. And therefore, you saw that there was nothing here because it was actually running on 81. And so this 0000:81, a visitor coming from the internet going to this port will be redirected to this port inside the container, is the promise here. So that's what this visitor is able to see. When the visitor goes to 81 port, the visitor sees Nginx running in port number 80 inside the container. I hope this crazy idea is clear to you. This is non-standard, but anything is possible as long as you know what you're doing. So that's what we did. Network mapping. You can very easily revert back to normality by not doing weird things like I tend to do occasionally. And you want to kill this guy now. So say docker rm -f v9, said guy's dead, and you want to do the right way, like what most people do. So you go port number 80 mapping to port number 80, and then you copy this whole thing, and then you run it here, and boom, you don't see anything on 81 anymore. You refresh and it will be unable to connect. There we go, 81, unable to connect. Make it 80, it connects. In fact, it even hides the 80 part because that is default. You don't even need to type 80 like this at all. There is no need. Just go like that. It opens. Because the traffic is going this time from 80 to 80 as opposed to 81 to 80 before. Questions on this are welcome. I hope you are understanding me. This is not standard. This is the standard. But if you dream of something, you can do it. That's the reason why I tend to go to the other clouds like DigitalOcean and Vultr and a bunch of others that are like give you total control over whatever the heck you want to do. And as long as you understand, you're fine. But that comes at a risk. The risk is that you may not know that you're secure. So you have to pay attention to these things and then make sure that you're secure, and then everything is just fine. Nothing wrong with using these cheaper clouds. It's just that the onus is on you, the adult. And being an adult, you can take responsibility and deal with it. So if you know how to do it, cheap is the way to go. It's actually faster. In DigitalOcean Cloud is actually faster for the same dollar amount spent than any other cloud. I'm not kidding. Go measure it yourself. I'm not saying that you use that cloud for production for your customers. I'm just saying that it is faster, at least from my observation. It actually is faster to load, faster to pull these things. Like you saw, pull happens faster. These things, I've measured it, and it runs faster. The CPU is faster. The benchmarks are faster. Not advocating that cloud by any stretch of imagination. Not saying that this is the best cloud. No, it is one of the most dangerous cloud you can use. So don't use it. Only for learning. It is an awesome cloud. And if you have something to play around, yeah, go there, play with it. Enjoy your true heart's content, like whatever the heck you want to create, it will let you do that. No limitations, because you get root access, and you get to control anything that you have in your setup. So that's the reason I tend to use those clouds. It is actually bad idea from a production standpoint to run on those clouds, because they don't give you these things, these what I call crutches. That's my choice of word, crutch. Is that the right way to spell it? Probably, something like that. So let me just check the spelling. I think that's the right spelling. But yeah, you need crutches or training wheels. Crutches. Yeah, you need those things as you learn to walk. So you can grab them. They are available in all major clouds. But if you know how to walk or run yourself without these things, you can. But again, in a production setup, it will make your customer happier to know that they're dealing with a cloud infrastructure from a reputed company with lots of money behind it and lots of history behind it. They might like some other clouds better than cheaper clouds that nobody knows about, like these guys. Like it's a fairly good cloud that gives you like a cheapest possible pricing today. And the pricing can be, but again, cheap is not the best. Just remember that cheap is not the best. Cheap means cheap. There's no other meaning to it. So here is your cloud. It's like a €2 per month. So maybe $3. So cheaper than $5. And still gives you 1 GB memory and all that good stuff. And so that's your pricing. And it works most of the time, I should say most of the time. That's a cautionary word. It works most of the time, which is a good thing. But just saying that don't go cheap. Go cheap only when you're learning or when you want to show off or any of those things. But fine. So let us understand the next idea. Cheap is not one of them, by the way. So you got the networks pieces, at least understood. So let's put it there. And now we will actually Swarm and Kubernetes, we should, let's see how we need an exercise for that. It's a fairly involved concept. So we have to understand a lot more about using Docker containers, about building images, about using images and sharing images. Those ideas I want to run first before we jump into these guys. So we'll leave them aside for now and come back to it next time. Maybe not exactly next time, but some other time. We spend quite a bit of time on this thing called Kubernetes because let me actually say this in a different way. Because what's the best way to prove the idea? Okay, here we go. So we go here. And what do we find here? We find here a way to look for trends in job categories. And in that, we want to say Indeed trends, Indeed trends Kubernetes. Let's see what pops up. So here is probably a good one. No, I think I did a better search. Trends. I want to see Indeed trends on a keyword. Yeah, we should find it here actually. So let's go search for Kubernetes here somewhere if you can locate. It's hard to locate these days. They used to have a better interface, but that is gone. What I was going to show you is a graph that shows you importance of Kubernetes over time. That's what I want to find out to see if I can build a graph. Of number of jobs available in the industry and how they are growing in Kubernetes area compared to other things. Doesn't give me quick answers. But I'll find something, a trend that shows a trend of Kubernetes maybe. No. Yeah, this may be a good one. So here. Why adoption of Kubernetes will explode in 2018. There is a blog post and here is the idea. 10 most discussed repositories on GitHub. That's a good one to look at. 10 most discussed repositories. So first one is Kubernetes. And how many thousands of discussions compared to other things in similar space? It's like an order of magnitude difference. Like the second one is like 100K and the other ones are even smaller. And Ansible is like 50K. But yeah, they're big projects here. And so this is the idea that I want you to focus on is this is the single largest exploding concept that everybody and their brothers and sisters are adopting. And this uses Docker under the hood. And you will see that there are services available from every major cloud, including the cheaper ones, that provide you a Kubernetes solution. So let us find out. Azure Kubernetes service. Azure has it. It is called AKS. That's the solution. Similarly, you have Amazon Kubernetes service. What is it called? EKS, Elastic Kubernetes Service. Then you have Google Kubernetes Service. What's it called? It's called the Google Cloud. Google Cloud is actually built on Kubernetes. Kubernetes actually is a Google product. Used to be a Google product, now it is open source. And you will see that this Kubernetes product is what I am using in my company to run in a bunch of workloads. These are my applications running these things, running in a Kubernetes cluster. You will see even DigitalOcean these days provides Kubernetes. The cheap company I was talking about, they have recently started a Kubernetes service. So you can create a cluster on Kubernetes using DigitalOcean and boom, like that. That's how it works. You can choose the version that you want and choose the location you want, like to get, like New York or Amsterdam. San Francisco is all booked, all fully occupied. So you only choice you have in the US is New York. And then you get same cheapo cluster, $5 a month, get 3 of them, $15 a month, and you get a cluster. This is the cheapest way to get a Kubernetes cluster, by the way. This. And so everybody is doing it. The reason they're doing it is that every customer is asking for it. So that's the whole point. that I want to cover Kubernetes in our discussions and make sure that you are up to speed on it. That's the whole point of the bootcamp, that you get up to speed on what's happening in the industry. And so this Kubernetes is going to be extensively discussed in the coming days, coming sessions. So we'll do these things at a great depth until you get tired of it. I'm not kidding. I'm not kidding. But at any time, if you get tired, you need to tell me that please stop, and I will stop. But there is already a ton of material that we will cover that. But now, having said that, let us now do something as an exercise to create an image in our own machine and then share it out with other people in the team so they can use it, for which you need to have a account on Docker Hub. So hub.docker.com is the place to go. And there you will create a new account. It's free. And that's the next action I would like you to do on the side as I go and find a place to create a new image for us, which is what I will be doing somewhere. Let me get rid of these two machines I have. Let me just kill them. So I'm going to kill these. We don't need them anymore. So here I have the Azure machine. I'm going to go to my resource groups in here and say all these resources should go away like that. So please kill. And the other cloud, where are you? Here, DigitalOcean cloud, there's a machine running there. You should die. So the machine is destroyed. Fine, both the machines are dead. I mean, this one is definitely dead. Azure is probably still busy killing it. See, still busy doing killing. The killing should not take that long. It's just a question of shooting the gun, but it's running something to kill. Fine. So when it kills, we'll get to a point where we have nothing. But now we'll look at an example of how do you create an image. And an image is basically a way of creating layers on top of your existing file system. That's the idea of layered file system. So the way you create an image is to actually use a file, just like any other file. We had chef file and Burks file and this file and that file. We will have a Docker file, just like that, Docker file. So Docker file will look like, let's see if I can pull up a ready-made exercise. So I'm going to close these command windows and this one. And let's see if I can find a quick exercise for us to play with. And so the exercise I want to play with actually is on GitHub. And what's it called? GitHub Cloud Genius Docker files. Let's see if that's a good exercise or not. Yeah, that's a good one. Yeah, that's a good one. Let's actually pull it. So we'll use it, but we'll maybe have to build some foundation for us to use this exercise. So I'll basically clone it now. I'll clone it, give you a link, so you can also clone it, and we'll study this exercise a little bit. So here is the link coming up. And I will now paste that link in your chat window for you and also clone it locally. So I have that folder coming locally available to me, and I will now use it. So that folder is called, what's it called? User Docker files, open. So I have a folder called Docker files open now here. And in there, what you will see are some examples. And let me simplify this idea for you. Let me quickly read it to get to a point where we can, I think this is a good one. So let us now prepare Okay, that's a good Docker file to look at. So let's understand this Docker file. So what we are looking at is a folder I am dealing with is called Docker files, which I just created using git clone command. In there, I'm using the scratch name to store some stuff, and which basically stores this detail, which we ran in the previous exercise, closing the scratch file and focusing on the Docker files folder, app subfolder, and a file inside there called Docker file. That's the file. We are going to deal with this now. Now let's go see what that file does. If you read that file line by line, it will help you understand some of the concepts of layered file system. Let's go see. The first line is very simple to read. It is beginning with the letter from, and it has some image name and a number. This is the basis from which we are going to build on top. So whatever you put on top of the basis is this and that and other things. Right? That's what you have to create layers. So this is your layer number one, layer number two, goes on like that in that direction. And in Docker file, you put a basis like this and you add layers like that. Every line is a layer. That's how you should think about these layered file system. So whatever you do is a layer. Some of these lines are not actually a layer. For example, line number 2 and 3 are not layers because they don't change the file system. The basis doesn't change by just me telling them that I am the maintainer. Doesn't actually materially change the file system. It is still the same after you execute these steps. All I'm doing in step number 2 is declaring that the maintainer is that person or that entity. So that's the idea of a layered file system written down in a Docker file. The layers go up on top of each other, but the Docker file is read like that, downwards from some beginning point and goes down. Let's see some examples now. So in here, that's an image. It's also called the foundation, also called the basis, is the beginning point. My beginning point in this example will be Ubuntu 14.04. That's just a beginning point. Then I have this line, which is not really making a change to the file system. So it's not, I can just strike it out for now. Looking at this line, it is setting up some environment called Debian frontend non-interactive. Basically tells me that I am going to interact, or rather not interact, as this Docker file is used to create an image. So you use a Docker file to create your image. And this image is basically a layered structure of stuff that you put on top of some basis from which you begin on the basis of this. So that's our basis. And then you add stuff. When you run this command called apt-get update, it updates something on the machine. So here, apt-get update becomes a layer. Next, we run something here, whatever that thing is. And so that becomes another layer. Then we have a comment, another comment. So they do nothing. Then we have another layer. This does create a new folder called that. That's a new layer. Then this is a comment. Then we have another layer. And we have another layer. That's how your layered file system is getting created and is going to be saved in an image using this Docker file. So we'll use this Docker file to create a new image. So let us do that. I'll erase my ink and then use this Docker file to construct a new image. And I have it locally in my laptop or desktop, or whatever this thing is. It's neither on my lap nor on my desk. That's why I call it whatever this thing is. It's actually a flat surface hanging in the air. It's not on the desk. So you've seen it, I think, before. This is what this thing is. You can look at it. Lights are missing. Lights. There we go. So light should come on. There I am. So now you can see what I'm doing. This is a thing hanging in the air, and therefore it is neither a laptop nor a desktop. But I'm going to use this Docker file to construct a new image. So in that folder, I need to go and, in that folder called Docker files, I need to be in the folder called apps. And there I find a Docker file, this file. And so using that file, I want to build a new image. So how do you build an image? You just say Docker build. And then you say, whatever I have in this folder, right? That's what you build. So you say dot, meaning this folder. And so it builds like that, just like that. I'm going to enter now. It builds. Docker build dot. Whatever I have in my current folder is what you build. So there is a folder called whatever dot, and that folder contains the Docker file, which contains these instructions. So that's the instruction set to create a layered file system. So it is building that. And you can see that there are various steps that will help you understand what it is building if you read and pay attention to what's going on. And by the way, you should also build your own image, or your customized image for yourself if you change the Docker file a bit, which is totally fine. Change it. But don't have to. You can change later. And so this is what will help us create a new image called 455 Echo Charlie F94, whatever that number is, that number. That's a new image created now. So let's go see what did it do. Docker images. So 17 seconds ago, there was a new image created called 455 Echo Charlie. It has no repository, no tag, no name, because we did not tell it any name. All we did was say Docker build dot. So dot means this folder. So it build whatever it finds in that folder. So that it finds a Docker file, so it uses it to build. And so it builds. So we said Docker build dot one more time and see what happens. Done. It quickly builds it, meaning it doesn't do anything because it's already built. So it says step number 1 out of 8, use the basis, the foundation. Step number 2, assign a maintainer. Step number 3, set this environment. Step number 4, apt-get. And by the way, it is using cache. There is a cache stored locally in var lib docker. You know that folder already. That's where it stores cache. And that is all stored already. So it doesn't have to run that command again and again. So this is not run again, not run again. None of these are run again. It's just using the cache. And it tells you to successfully build this image. That's this image right there. 17 seconds ago, maybe now 3 minutes ago. And that's the image now available. But we did not give it a name. So we should give it a name, by the way. And if you have created an account on hub.docker.com by now, using a name such as whatever your name is, so say name, that's your login name. And so you should now assign names to this image that you created by giving it giving the machine a name. Sorry, wrong word choice. Giving the image a name. The name that I would like you to give will be looking something like this. In my case, my name of my company is Cloud Genius. So the name of the image that I want to give is a slash. And then I can choose whatever this name is. XYZ. So that's how you should structure your names of your images in your Docker Hub. Your name may not be this, your name will be something else. So you should have that something else followed by the name of the image. That's how you should name your images. Because if you name it like that, there is a benefit to it. The benefit is that you can push your images to Docker Hub. Excuse me. What we are going to do is assign a name to this image. How do you assign a name? You just ask it to build again and say Docker build. And by the way, when you build, use this tag. The tag is cloudgenius/xyz tag. That tag, take this tag and build whatever I have in that folder called dot. Boom, it builds. So all it did this time with a new tag was with a dot at the end, by the way. The dot picks up the Docker file, and this -d option passes a tagging, which means now I have a properly tagged image. Image was created 4 minutes ago. The name is the number is still 455 Echo Charlie, but the name is tagged correctly. And we have the latest tag. So that's the repository called Cloud Genius XYZ is where I can push this image to Docker Hub, to my registry, to hub.docker.com, simply by saying docker push. That's what I want to run now, and I will push to my Docker account this image with this ID 455 Echo Charlie. So let's go push. So I'm going to clear the drawings, and before you push, it might fail on you because you need to log in. So Docker push Cloud Genius will fail. Or maybe, yeah, it did fail. It failed because I need to log in. So it says denied access, denied requested access to the resource is denied, which means I need to log in to Docker. How do I log in? Docker login. That's how you log in. And then you type in your username. And then you type in your password, which is, I have no idea. We'll find out what the password is. And the password is that. So I copy it and paste it. And then I log in. So it succeeds. And then I can push again. And this time the push will succeed. Which means all these layers are getting pushed, the layers that I created, the ones that indicate, and that are indicated in my Docker file. So they're pushing the changes that I made to the basis. My basis was Ubuntu 14.04. My changes are captured in the Docker file. The changes are reflected in the XYZ image. and they are getting pushed. And push should complete any moment soon, which means the push succeeded. This digest shows the push succeeded, which means I can go to my Docker Hub account. So hub.docker.com, and you should see the image right there. Once I sign in and I type in my password, I should see that a new image was pushed to the Cloud Genius organization called XYZ, and search for it. So where is it? I don't see it. Boo. Where is the image? Oh, it should be there somewhere down. Maybe on the next page. Oh, I pushed it. Where did they go? Okay, it said success. Size is success. The name is Cloud Genius XYZ. So come on, show it to me. It takes us sometimes a little bit of time for the website to show it, but it should be there. Let's go hack it. Let's go hack it like this. So just make it XYZ and it should pop up right there. There it is. And what I did was a URL hack, and I modified. I went to another playback repository right there, and then I changed the word playback to XYZ in the URL to get to the list, the actual listing. And that is this pushed a minute ago, and you can pull it like this. It's a public repository. You can just pull it on any other machine or even this machine. So you can say Docker pull, and it will quickly pull it and say, yeah, I already got it. No need to pull. So I already up to date. There's nothing to pull. I already have it. The file image is up to date. There's nothing to pull. However, if you just go to a different computer, and in there you have, let me see if I can get to another machine here. And there I have Docker images. I have 3 of them apparently. So I'll pull another image, and it will pull in the other machine, which is pulling right now. You can see it. So anybody can pull on the internet, get this exact image, and I can just share it with the planet if I like, or limit it from sharing with the planet and only give it to my team members. The limitation of giving it only to your team members can be set in a private registry. This is a public repository, which is free. Private is not free. You have to pay for it or run your own registry. So if you run your own registry, you don't have to pay, but I think you can create a private repository. I think maybe 1 or 2 is allowed. Create a repository. I think you probably give you 1 or 2 free private ones. I think if I have a private repository, how many do they allow? I don't remember how many they allow or not, but it's a commercial thing. I'm not interested. All I am really interested in is the public repositories, which I just showed you. And you can go to the dashboard and probably see the Cloud Genius XYZ repository now popping up eventually in the search results. No, still not popping, but who cares? You already saw it. So the next idea here before we close, the key idea I want you to be able to do is to create your images and let me pull it, or you pull my image, one of those two. And when you pull it, you should be able to run your image. If you feel like there's nothing, this Docker file is kind of dumb. It doesn't do much interesting things yet. So it is just a starting example for us to discuss what can you do with the Docker file. We have various steps to go through in this exercise. It's a multi-step exercise, but we are just beginning to explore. So that's the first step we saw in this example, is to just see what is a Docker file, how do you create an image, and how do you push it to the Docker Hub. If you want to run your own private repositories without having to spend money, you need to go search for the registry image. And there is this image called registry, which lets you run a Docker registry, which is like Docker Hub, on your own machines for free. And this is open source. So you can see how the registry itself was built using a Docker file right there. This Docker file is the Docker distribution library image, which is how the registry was made. You can see the Docker file right there, a minimal distribution container. So that's the Docker file for the registry itself. You can take this Docker pull registry and run your own registry pretty much like go to a machine and say Docker pull registry, and now the registry is coming down, and then I see Docker images, and I have the Docker registry images there, and it was created 6 weeks ago. The size is 33 MB of the image, and I can run that image right here on this box called Chrome box, is one of the machines in the garage. I can run the registry right there, and that will give me a private registry. So that's one way to handle. The other way to handle is just pay money to somebody and let them do it, like I do. In one example, I don't worry about creating my own registry, but I actually use the Google registry. So console dot, how do I type it? Console, there we go. And so here you will see somewhere there is going to be a Google Cloud registry. Where is that? Clusters, applications, storage. Where is the AC Google Cloud registry? It has to be a container registry right there. Images, I have one image there, 2 images. This one image is the one that I use for my NFS server. That is the image. It is called Be a Cloud Genius NFS server, which is where I store my stuff, my NFS solution, in the production deployment of all the services that I run. I need a server to store my stuff outside of the machines. So that's the image that I use. How do I build that image? Let's go see it. So we'll go see that image. How was it built? By looking at its Docker file, and it is somewhere here is where you will find the NFS server, and it is right there. And this is poor man's NFS server, not for production. I just wrote that down because I don't want people to complain, but it's a pretty good solution. People will copy it and then come back and complain that this is not good for production for them. Fine with it. It is good for my production. So I use it, and I want you to read it. I want you to study it. But again, remember, this is not for production. This is just for me. I create stuff only for me. And when people understand, they take it and they can modify to make it theirs. So here's another Docker file. It's a very short one. It begins with something like CentOS, and then adds a bunch of things like run this, run that, add this, add that, and expose certain ports. These are the ports needed for NFS to work. And then when you want to start the NFS server, you run it like this. That script is written down here in that location, and that's the script. That's the NFS server script. Now this is a very short one to get to a quick solution, and therefore it is not comprehensive. And people on the internet just want to complain if you write something that is not for production, you claim that it is production. That's why I have added that line called poor man's NFS server, not for production, just to tell people that, what, stay away if you don't like it. But it works. It is right here, working for all these services that you see in Cloud Genius, and is just my NFS solution, my NFS server, because that's what I have. I can use other solutions like EFS from Amazon, or the Azure files from Google, from Azure. Yeah, Azure file storage. I can use these guys, but I'm not on that cloud. And Google doesn't yet offer an NFS solution like these guys do. Doesn't yet do that. But there is an alternative solution available that Google thinks is decent. So they have this idea of file servers on, so you can see what these things are doing. Let's go check. There is a good solution for NFS for Google Cloud. What is that solution called? I think it is this single node file server in the cloud marketplace. And that's the solution that Google is advertising. So you can just start that, launch on Compute Engine. It will create a new single node file server. But as you will notice, when you go back a step, they claim that this is not an officially supported Google product, which is similar to me saying that, hey, it's not ready for production. So basically, they're like writing these things down in black and white, saying it is not supported officially Google product, but it is right on their website. Right there, it's Google's site. So, by the way, it works beautifully. It's just that Google doesn't want to support it yet. So they're not ready for it. They will eventually come up with a service like these guys, Elastic File System in the cloud, or like these guys, Azure Files, Windows Files in Azure Cloud, like NFS service from Google will come eventually. It's not there yet. Maybe it is there. Who knows? I haven't checked. Maybe it has popped up. I haven't bothered to check, but we'll check. So go to console and see if there is an NFS solution already available. And there maybe not, maybe it is there, but we'll find out. So go to storage, file store. Apparently there is something popping up here. No, not this. I may be in the wrong account. So storage again, storage, file store, data store, storage, browser, transfer appliance, file store, data store. I don't see it quickly yet. So it might come at some point. There's double file store here and there's fire store. Okay, that's the difference. So this is the one you should read. Fire store and file store. That confused me a little bit. So this is your file store API as opposed to the other one was fire store, and apparently something is new. So enabling a new API for file store API for your project. Apparently there is something new that I was not using before. So it is enabling the API for me. We'll find out what this thing is, and maybe if I like it, I'll use it. Maybe this is the one I was looking for and waiting for that I haven't used it yet. But the point of this thing is to say that you can use Docker file like this to create your own images and run it for real. That's the whole point. We'll do more exercises, and specifically this exact exercise quite a bit. There are multiple steps to understand. We'll do those things next time. Right now, I am going to stop recording and I will resume. You should, hold on, let me say one thing. Today is what, 29. That means you should have a new certificate available for you to download from the Bellevue College website sometime in this week. You should download that and make sure to submit it to LTP as quickly as you can for obvious reasons. That certificate should become visible to you in the next couple of days. I hope you will receive an email from Bellevue College about that, because today is the official last date for Cloud DevOps segment, which produces another new certificate. And so that is what you should download and make sure to submit to LTP. With that, I will now stop recording.